1997 BC 17. F is the function given by f of x is ln of 3 minus x. We want to find the third degree Taylor polynomial for f about x equals 2. So this is a case of, given a function, we need to be able to use the general form of the Taylor series and to find the third degree Taylor polynomial. And so I've written here the general form of the Taylor polynomial. It is, each term consists of the nth derivative of the function f, evaluated at a, the center, divided by n factorial times x minus a, again the center, to the nth power. So in this case we're looking for, and the first term is always going to be f of a. So we have f of a, then we have plus the first derivative of f evaluated at a divided by 1 factorial, and then times x minus a to the first power. Second would be second derivative evaluated at a over 2 factorial times x minus a to the second power. And finally, third derivative evaluated at a over 3 factorial times x minus a to the third power. And it goes on from there. So in this case we are looking for f of 2 and then plus f prime of 2 times x minus 2 plus f prime prime of 2 over 2 factorial times x minus 2 to the second plus the third derivative evaluated at 2 over 3 factorial times x minus 2 to the third power. Alright, so f of 2 is, let's find some place to do that, that's f of 2 is ln of 3 minus 2, which is ln of 1, and we know that is equal to 0. So the first term is going to be 0. Alright, now we need the first derivative. So let's find the first derivative. F prime of x is equal to 1 over 3 minus x times negative 1 using the chain rule. So that would be negative 1 over 3 minus x, and f prime of 2 is going to be negative 1 over 3 minus 2 is negative 1. So for the second derivative we have negative 1. So right away we can tell that we need to start off with negative quantity x minus 2. That gets rid of c, d, and e, and we're down to 2 possible choices now. We need to go into the second derivative. Second derivative of x. Well, if the first derivative is, let's just do a rewrite here, is negative 3 minus x to the negative first power. And so I'm going to bring down the negative 1, that'll be positive 3 minus x, and then times the derivative of the inside is negative 1, 3 minus x to the negative second. And so we're still going to end up with negative 1 over 3 minus 2 quantity squared. Evaluated at 2, that would be negative 1 over 3. I plugged in the 2 there originally. Alright, so that's better, and that's just going to give us a negative 1. So that means that the second term has to be negative, and so our answer is going to be B and cannot be A. So that does it for that. Again, if you wanted to make sure that you were definitely on the right track, you should do the third derivative and make sure that it follows suit with the rest of selection B there. But that'll do it for this question.